All right, so for those of you who just wanted to learn basic definitions and concepts, you might want to skip this next part, but we're going to go a little bit more into the details of these simple models so that you can better understand the different variables at play during our enhanced greenhouse effect model, which we'll be getting to next. So a concept that we have to introduce right here from physics and chemistry is called the principle of thermodynamics. And thermodynamics is all about how energy can't be created or destroyed. So what we're really saying is that any energy that you put into a system has to come out in an equal amount. So before we were talking about heat, and heat from the sun, how that heats up the earth, and how the earth can release heat. So instead of saying heat now, we're going to say energy. So the energy, or the energy in, is all coming from the sun. So heat in the form of energy is being transferred via space, and the earth is able to absorb that energy and then release energy as well. And so the earth is able to release energy, aka energy out. And so we just said energy in has to equal energy out. So whatever you put into it from the sun has to also be released by the earth in an equal amount. And so climate scientists have come up with this very simple climate model, and they figured out what factors actually make up the energy coming in and what factors make up the energy going out. So very simply, we're going to say that energy in, so that's that E in, this line here, it depends on the intensity of the incoming sunlight. So how much energy or intensity is being transferred from the sun to the earth. We also, the other variable is how much sunlight is actually being absorbed by the earth and is not reflected back out into space by things like snow, clouds, ice, all of these things that are white and that can reflect sunlight back out into space. So this is actually called the albedo, A-L-B-E-D-O. So the albedo effect is any kind of sunlight that doesn't reach the earth at all, but is reflected back out into space. And then the third variable that impacts the incoming sunlight, the incoming energy, is what area of the earth is actually absorbing sunlight at any given point in time. And so we know during the day, the sun is actually only facing one side of the earth. It's not reaching all around the earth, but just one side. So we estimate the area of sunlight that's actually being absorbed by the earth to be an area of a circle. So then on the other side of the equation, we talk about this energy out and the variables that impact that. So, and these are simply what's the temperature of the earth. So depending on how hot or cool an object or like the earth is, it will either emit or release more or less heat. And heat is temperature. So we can measure the temperature of the earth. And then what also impacts energy out is the area of the earth that is releasing heat. And it's actually all over the earth is releasing heat. So we say this, we estimate this to be the area of a sphere, just like the earth. So again, those are the things that really are playing into the energy coming in versus the energy going out. So the big factors again are the intensity of the incoming sunlight, how much light is being reflected off of clouds, snow, things like that. That's called the albedo. And then the actual area of the earth that's able to absorb sunlight at any given time, which is a circle, the area of a circle. Then going out, we have what's the actual temperature of the earth. And that really is saying how much energy is being released by the earth. And the higher the temperature of the earth, the more energy that's being released. And the last thing is the area of the earth that's releasing this temperature, this heat at any given time, and that's the area of the whole earth, so the area of a sphere. So that's without the greenhouse effect. So all the energy coming into the earth is then going out. in our other scenario where we have the greenhouse effect, and we represent that by a piece of glass, like with a greenhouse, the wall of a greenhouse. So now we're saying energy in is the same thing. Because of the nature of this piece of glass, all the sunlight is able to pass through that piece of glass and to be able to be absorbed by the earth. So everything that we talked about over here is exactly the same, basically, in our nice system. So this is the same thing. In terms of energy going out, it's the same variables, but now we have this piece of glass. And the nature of the glass is that all the energy going out from the earth, is now absorbed by this piece of glass. And once it does that, then the piece of glass can also release this energy. And so it can release it upwards, out towards space, but then it also releases energy back down to earth. So now if you see this, we have, part of the energy going out to space, but part of the energy is coming back down. So what does this mean overall? It means that the energy out up here is actually less than the energy going in. And why is that? Again, because some of that energy is being reflected back down to the earth. But I just said to you, thermodynamics, any energy going in must equal the energy going out. So how does the earth compensate for this? So remember, if we go back here to our little energy balance equation, everything over here is basically constant. The only thing that can really change is the temperature of the earth. So if you think about it, what has to balance? If the overall out here energy going out is less, well then the temperature has to compensate by increasing. And so that's why the Earth's temperature is hotter, actually, when you have the greenhouse effect, because that's the only thing that can compensate in this balanced equation here. So again, the greenhouse effect works because this glass absorbs any heat or any energy that's coming from the Earth, and then it's able to emit that heat or that energy back out up to space or back down to Earth. And so all that can happen then is that the temperature of the Earth increases.